The Egyptian desert is one of the most hostile environments on Earth. Summer temperatures can reach 120 degrees Fahrenheit, and humidity often drops near zero. In open terrain, a person without shelter or water would collapse within hours. Yet 5,000 years ago, entire cities thrived here. Families lived, worked, and built monuments that still stand today. Egypt's heat could kill in hours, yet its cities stayed cool for millennia. How? The answer lies not in modern technology, but in an unbroken chain of environmental engineering. Egyptians learned to read heat like a language, shaping their world so completely that survival became architecture. Their challenge began with geography. 95% of Egypt was bare desert, but every year the Nile flooded, leaving a narrow green corridor between wasteland and water. This sharp contrast forced precision. Every wall, street, and schedule had to balance between extremes: blistering sun, dry wind, and the brief humidity that followed the flood. Their first tool was earth itself. From Nile mud, they created the material that would define Egypt's civilization: mudbrick. At sites such as Amarna and Deir el-Medina, archaeologists have measured walls up to a meter thick. Modern tests show that these walls kept interiors up to 15 degrees Fahrenheit cooler than the air outside. The science was simple. The outer surface absorbed heat during the day, while moisture trapped in the clay evaporated slowly, drawing warmth away. At night, the walls released stored energy inward, keeping rooms stable as the desert cooled. Mudbrick construction turned heat into rhythm. Homes were oriented so their narrowest sides faced the sun. Windows sat high, small slits designed to vent air rather than admit light. Courtyards in the center of each house acted like lungs, where hot air rose and escaped while cooler air flowed through shaded corridors. The effect was a natural air conditioner that ran perpetually, powered only by wind and evaporation. The same logic scaled up to the city itself. At Amarna, the short-lived capital founded by Pharaoh Akhenaten around 1345 BCE, streets were deliberately aligned with the north wind. The layout created permanent shade, while airflow moved predictably through the settlement. Even without mechanical systems, the city breathed. Archaeologists have compared it to a vast wind tunnel, a deliberate feat of urban climate design. The device that made this possible was the malkoff, or windcatcher. It was a simple vertical shaft, open at the top and facing the breeze. Air entered the opening, was forced downward into the house, and then rose again through vents on the opposite side. Hot air escaped, cooler air replaced it. This principle, differential pressure, remains one of the most efficient passive cooling systems ever invented. Tomb paintings dating to 2600 BCE depict similar structures, suggesting the concept was already ancient in the Old Kingdom. Below ground, Egyptians developed another layer of thermal control. Many homes contained cellars or storage rooms dug several feet beneath the floor. Soil temperatures at those depths remain nearly constant year-round, usually in the upper 60s Fahrenheit. These subfloors were connected to main rooms by vents, creating steady upward drafts of cool air. Without knowing the word convection, they built its perfect model. Water became their second great technology. Clay jars known as zir pots or cod were left half-buried in shaded courtyards. The porous surface of the pottery allowed moisture to seep through and evaporate, cooling the contents. Tests with replicas have shown that this technique can drop water temperature by more than 10 to 15 degrees. When grouped together, these jars chilled the surrounding air as well, creating natural refrigerators thousands of years before electricity. At some settlements, archaeologists have found traces of shallow clay-lined channels across floors. These may have been used to pour small amounts of water, spreading thin films that evaporated and cooled the air. The same principle, evaporative cooling, is still used today in modern desert architecture. Clothing completed the system. Egyptians wore light-colored linen woven from flax fibers so fine they reflected sunlight while allowing air to pass through. Samples preserved in tombs at Giza and Saqqara show weave densities that rival modern breathable fabrics. Each garment was both protection and adaptation, turning the body into its own thermal regulator. Even time became part of climate management. Work began at dawn, paused at midday, and resumed near sunset. Markets and public gatherings followed the same rhythm. Religious rituals often coincided with the cooler hours of morning or dusk. Every element of society, from labor to faith, synchronized with the desert's pulse. The same principles governed Egypt's most enduring monuments. The pyramids and temples weren't just symbols of power, they were machines of heat management. The limestone casing stones of the Great Pyramid once shone white, reflecting sunlight so effectively that the structure could be seen for miles. Inside, air shafts and massive stone volumes stabilized internal temperatures around 68 degrees Fahrenheit, even when the desert outside reached triple digits. The combination of thermal mass and airflow created a constant equilibrium. At Karnak and Luxor, temple design turned shadow into a science. Massive columns rose 70 feet high, breaking sunlight into patterns that shifted through the day. The floors stayed as much as 40% cooler than exposed ground. Pools and basins placed near entrances weren't purely ritual. They enhanced humidity and created localized cooling. The entire architectural experience, from blinding courtyards to dim halls, followed a thermal gradient as precise as any modern HVAC system. These innovations weren't accidental. They reflected a philosophy deeply woven into Egyptian thought: the pursuit of ma'at, or balance. In religion, it meant justice and order. In architecture, it meant equilibrium between sun and shade, life and environment. To live correctly was to live in balance with the elements. That worldview produced remarkable continuity. For more than 3,000 years, Egypt endured droughts, floods, invasions, and dynastic collapse. Yet its systems of living persisted because they worked. A family from the Old Kingdom would still recognize the design of homes built 2,000 years later. Modern engineers are rediscovering the same logic. A 2019 study by Egypt's Housing and Building National Research Center found that homes using traditional materials and passive ventilation required 60% less energy for cooling than concrete structures. Architects across North Africa now experiment with updated Malkoff towers and thick earthen walls to reduce energy costs in rapidly warming climates. Tests at research stations in the United Arab Emirates show interior temperature drops of more than 20 degrees using these revived methods. Even NASA engineers studying habitat design for Mars have referenced Egyptian principles of thermal mass and passive airflow. When technology must fail gracefully, ancient simplicity still wins. For the Egyptians, sustainability wasn't ideology, it was necessity. With limited wood and minimal rainfall, they couldn't rely on external fuel. Every design choice conserved resources. Thick walls meant fewer fires for warmth at night. Reflective plaster reduced cooling needs by day. The civilization's longevity, more than 3,000 years, was built on those physical efficiencies. The same principles guided their social systems. Food storage, water sharing, and community planning were forms of energy management. Households shared courtyards to multiply shade. Wells and cisterns were public, positioned where wind and dust could not contaminate them. These weren't isolated innovations. They were interconnected systems designed for one goal: survival through balance. In that sense, Egypt was the world's first sustainable civilization. They mastered energy efficiency before they named it. Their cities functioned on renewable power, sunlight, wind, and time. The science that kept a house cool also built a temple that could stand for eternity. Today, as modern cities face record heat and energy scarcity, Egypt's solutions remain astonishingly relevant. The same physics that stabilize temperatures inside the Great Pyramid can inform carbon-neutral housing. The same evaporative jars can inspire low-cost refrigeration in off-grid regions. The same orientation to wind and shade can cool modern neighborhoods without burning fuel. When we look at Egypt's legacy, it's tempting to focus on the monumental, pyramids, pharaohs, and gods. But their greatest achievement may be invisible: the way they engineered comfort out of climate. They turned sun, air, and mud into tools. Their solutions outlasted the empires that built them. Stand in an ancient street at midday and you can still feel it. A faint current of air drifting through stone, cooler than it should be. It's the trace of an equation solved 5,000 years ago. Egypt's builders didn't escape the heat, they understood it, and that understanding still shapes the modern world.